All right, so we're going to fix some different problems. I'm ad-libbing this just a little bit. So we're going to start with number 3. And we'll go from there. So it says, what is the conjugate base of the bicarbonate ion and of the formic acid? So I want to know, I write these out. I want to know what the conjugate bases are of those ions. Is conjugate base of the bicarbonate ion or the formic acid? So what does the conjugate base look like? So what I want you to do is think about what that means. What I'm having you think about is then whatever I have here, like this is what I have right now, I want to know if these are linked together. This is the conjugate base. What does that mean for the X there, which is what we're calling the HCO3 and the HCO2. And we would probably have 2 other things here. That these would be linked together, so this would be the conjugate acid as an example. How does it all link? Okay, so if you have no idea where to go with this, this could easily be a test question. So it's important to think about, okay, what's the next step? What does it mean to be the conjugate base of that thing? I'll give you about 30 seconds to start, just at least trying to get one down. And then we'll answer the second part of the question in a second. What would it mean to be a conjugate base? It means that when it comes back this way, that it gains an H or loses an H. Comes back this direction. What does it mean? Loses? Gain? Okay, so that means that this thing has to be the acid. Right? So aren't these acting like acids right now? Right? Okay, so what did we write? Actually, I want to see. I did something else weird. We're not going to go in the same direction as the other thing at the ending. But if this is HCO3, the conjugate base should make sense that this is CO3 2 minus, right? And this one should be CHO2 minus. You're losing an H because you're acting like an acid. You shouldn't look at that and go, well, I don't understand what's the result of it. If I lose an H, I lose a positive, so it becomes more negative. So I would strip off the most common sense of what H would be detached is usually on the exterior formula. Then I asked, which is the stronger base? Now, we don't have information. If I gave you information, that'd be great, and they're assuming that you have some. But we don't. But how would I know which one is the stronger base? Any thoughts? You'd have to have blank. Emily? No. Good thought, though. Not as much. Jeffrey?
Does the charge make a difference?
It's a good idea as well. No? You need a KB, so you also need Ka. These are my acids, so the acids would have Kas. So these would have KVs. So if you only knew about these, let's just talk about it in terms of the acid, because usually we're given in terms of acids. How do I know which one is the stronger K or the stronger base? And they're assuming that I'll tell you this right now. They're assuming that you have access to Kas. What if I gave you Kas in the test? How could you tell me which one is the stronger base? Sorry, I'm sure some people said right answers. So I want to. Rory.
One with the higher pH.
Maybe, because if you have pH, you might have pKa, but no. Because pH also links to amount of present. And I don't know how much is actually present, but we're heading in the right direction. Again, I'm telling you, I'm giving you this. I'm giving you Ka. So I've got to figure out which one's the stronger base.
Lower K.
The smaller the Ka, which would, like value, right, would make a stronger Kb, because Ka times Kb equals Kw. So there's always a ratio. that makes sense? The bigger the K, the stronger it is. Strength just means going to the right. Or in this case, for the base, coming back this way. It's not the same thing.
What did I say?
You said pH.
Okay.
So the smaller the Ka, which means the weaker the acid, the stronger its partner. The weaker its the stronger its partner, the weaker the other side. I'm saying partner the wrong way. So whatever I'm starting with, its conjugate partner will be the exact opposite. So the stronger it is in the beginning, the weaker it is on the other side. If it's weak in the beginning, the stronger it is on the other side, because it'll always lie one direction or the other. So if this one's really strong, it means it's going to lie that direction further. So that means that this side is going to be really weak, trying to push it back the other way. Okay, so then this is a stronger acid. This means this is a weaker base. Vice versa. If this is a weak acid, this would be, and I don't know which one's which. I don't have the values in front of me. That would be a stronger base because this is a weaker acid.
So if it has a higher Ka, that means that it's a stronger acid, right?
Stronger acid, yes,
Okay,
which means
so
its partner conjugate base would be a weaker base.
Yeah, okay.
Would that ever be used as a strong acid?
No, it would ever be used with a strong acid, no, because usually we won't have Ks. And this can only work. It can only work in a partnership. I can't say like some random acid, let's say HCN, and then I compare it to CO3 2-. It's like those aren't the same. It's the partnership between them. That's the only way these work, by the way. It's not any acid and base. There's a partnership there. Because obviously that wouldn't make sense if you have a really strong acid and then you have a really strong base. And you're like, oh, wait a minute. Like, no, they're linked together. Okay? So if you're given that, we're going to practice that one more time tomorrow as well. But I wanted you to see that, but you should be able to do this as well. Now, I'm going to actually make you label just like on our first day of this whole chapter where we write A, B. We're going to practice it tomorrow quickly. C, A, C, B. And you put them underneath again. Easy points, I hope. Maybe not, though. All right, let's just do one I want to see. Let's do number 2A, but we're going to do, and then we're going to do to 5 as well. I'm kind of combining the two. So I want to see what this looks like. So what's the expression look like for 2A? So write the dissociation reaction because I'm linking it to number 5. I also want to do 5. So I want to do 2A within 5. And then I want you to label A, B, C, A, C, B. I probably should have just done that one first, but I saw 5 and I'm like, I want to do that. Well, I'd rather get 2A in there first. Now, technically, this is an acid, so I'm going to have these written out. If I said, hey, this acid reacts with water. So some of you that didn't do that, you're not doing it wrong. You're doing it fine. If you just want to throw it up on top, you definitely can. Reason why with water, or with acids, we don't need to write H3O+, we could write H+. It's assumed. With a base, you have to have H2O, or else where does the oxygen come from? So on the other side, if you just did H+, you were more than fine, and then that's what that would look like, by the way. If you took out an H somewhere else, just keep kind of thinking, I want to have the H that is exposed. So that H is exposed. This is actually a carboxylic acid, by the way, just so you know what it would look like. So it looks like this, and then the rest of the chain. So that's why this easily is removed compared to all these other H's. This is the easiest one to be removed from that. So if you haven't already, please put A's and B's and CA's and CB's under these. And I fully expect that we have that down, but I want to just make sure. Because then I want to just do, if you want, once you're done with that, if you want to go to 5, I want to know what the equilibrium expression is for this reaction. And what do you think that looks like? And if you're like, I don't know, just we're confused by our phrasing. The whole A-B thing, by the way, once you get it started, you should be all locked in. Once you give 1, everything else is locked. So like if you say this is an acid, automatically its partner has to be a base, right? The conjugate partners are the exact opposite, just with C's. So this is linked to that, and you don't necessarily have to do these lines. If that's the acid, this has to be the conjugate base. So then if that's conjugate base, So it has to be the conjugate acid. I mean, that just feels right. Just write it. So, I'm asking you to do a K value. You should do it in something like this. Hey. Yeah. And so- Yeah, everybody's typing.
No, that's fine.
Yeah, but I got cash for it.
Okay, thanks.
Ellen? Because this is a weak acid. So that's why I'm doing it that way.
So if that was a base,
Then I have OH on the right.
yep, so then it would be KB.
Correct.
And what if those are strong?
Wouldn't be doing a K expression at all. No, that's a good question.
Is the H2O just not going?
Correct. The reason why doesn't H2O go in there? It's a liquid, right? Liquids don't make it, right? You got aqueous or you got gas. And that's it. All right. Let's go to number 11. Actually, let's do this first. Let's do 10. Make sure that we're there, and then we'll get into some bigger problems. Now I'll get into much bigger ones really quickly here.
Mr. Gussie?
Yeah.
Can we put H plus instead of H3O plus up there?
You definitely could. It all depends. If the equation is written as such, though, then it has to say H3O plus. If you had written H plus, then yes. Go by what's written. So I want to do this in different ways. I want to try to solve this in some different manners. And I'm not saying any one way is right. What's nice about a lot of pH problems and concentrations is there's more than one way to do it. Okay? So, how can I find H plus? Let's just do this as a conversation. If you're already ahead of me, that's awesome. But what could you do? 10 to the negative 11. 11.93, yes. Beautiful. I don't have my calculator. You gotta help me out. That should make sense. It's a small number. Why does that make sense? Because this is a really high pH, which means it's really basic. Right? I don't have a lot of H plus. Okay. One way of doing this, and I'm going to show you a different way, but what's an approach someone could take? If that was the only question. Jeffrey? No, you tell me how you do it. Let's pretend, are you going to use this? Or are you going to...
I just used OH times H plus is equal to 1 times 10 to the negative.
Okay, so you're saying basically KW over H plus will equal that? Is that what you're saying? Definitely. To me, that's the shortest route. Now, I guess I kind of handcuffed you there because I said you couldn't use what we just had, but obviously we have it. So that's the way I would have done it if I had the information I had. That's the shortest step you could take. Molly, were you saying a different way? Is that the one?
We can say it.
Yeah.
You would find POH and then do that.
So we're going to take 14 minus that,
Yeah.
and then 10 to the negative POH. Good. And then you would have actually, so then how do we get this one? Just 14 minus this. What's another way within the context of what I all have here? Let's just want to just to make sure that there's always two ways to every single problem.
Lost where we are. I'm just.
Super.
You just take the negative log of the OH.
Yeah, if you take the negative log of the previous answer we just had, you get the POH as well, correct? There's always two ways to do it. Always. So, you know what I love about that is that you could be sitting next to somebody who you guys see the same problems the same way a lot of times, and all of a sudden you see it one way and they see it the other way. And yes, maybe you pick the one that has one extra step. Oh my gosh, heaven forbid, it took you an extra 40 seconds or 30 seconds. It's not like it's some huge long path. is only a little bit. So you can definitely do anything you'd like. I mean, the easiest one for this one would be obviously that, right? I mean, if we're doing one-step problems. Okay, so it's important to know that stuff should be all on your yellow sheet, and we should be pretty confident about that. Right.
Okay, well, I got a different answer for the H plus, and I don't exactly know like why it would be different. Like I got a round, but I got 1.25 times 10 to the negative 12, which was kind of. I put in, I found POH.
Okay, the minute that you do it a different way, there's going to be some rounding. You probably cut some of your numbers off, unless if you actually use the
I
answer.
just used the answer key.
I don't know.
Okay.
But it does vary a little bit depending on what
Okay.
direction you do go, but it still would have been acceptable.
Okay, okay.
You're good. You are good. All right. Give me one sec.
I mean, OH.
What's the whole
Yeah, OH.
All right, let's go small and get bigger here.
Yeah, concentration. From POH there again. From 10 to -2.1.
All right, we're gonna not worry about the entire thing. Let's go down to 28. There's a lot of things in 1 through 26 that they're great, but all it is utilizing the equation that we just discussed. Okay, at some point it's like, all right, fine, I get it. You can use the negative logs, and you understand the KW relationships, and you understand the difference between H plus and OH minus. But at some point we just got to jump into this. So if I have a 0.01 molar solution of HCN, Ka equals 6.2 times 10 to the negative 10th. And what I want, let's do this. I want, ultimately I want pH. I know that's not what it says, but let's take it one step further. So, necessity to do an icebox. Like 100% to, 100% yes, or if it's less than that, you don't necessarily need to. Yes or no, you have to do an icebox. You don't have to. Does it potentially help you depending on where you're at? It could. As I was saying in class today, what I think is smart sometimes is to start an icebox, and then if you're like, oh, I'm good, like I'm recognizing this, and I hope you understand where I'm going with this. If you're realizing there's nothing else involved and it's just initial amounts, then eventually I can bail on my icebox. But what if in this question, AP questions are famous for setting this up. So even if you've started it, please do this on the side. What is the dissociation equation? And you can make a very simple one. It will ask a lot of times, just, hey, letter A, write out the dissociation of this weak acid. You should understand what I mean by that. So anybody just want to ad-lib this with me? What am I going to write?
H plus C.
Is that right?
How do you know if it's an acid? Oh,
It's almost right. I'm being really, really picky. Because it's weak. It's got to go both directions, okay? Strong drives it all the way to the right. Weak is barely actually going to the right. If anything, of any arrow, it's almost more important for the one that's going to the left than the one that's going to the right. I mean, what a weak acid means is this, truly. If you were like illustrating it with pictures, like it's barely going to the right and it's going to the left a lot harder. So I'm not going to set up the whole thing, but just so we're very clear, there will be a question like this. Like just, hey, can you just tell me a pH or an OH or an H plus or whatever? So that's great. Like a lot of times what I do, or you'll see, like I'll start it and be like, all right, I'm good. And I may not even do the ice. I just might write it underneath, like I see it. So, and I just want to start with this so we can jump to the next level problem. So hopefully I didn't pick a problem that, oh good. Let's say I don't want to do quadratic right now. Why am I confident that I'm not doing a quadratic right now? Yeah, that's small, right, compared to my initial. Yeah.
Why don't you have to add H?
Great question. With an acid, you could. A base, you have to. Just the difference is if I added H2O here, this right here would be H3O plus instead of H plus. An acid, we can do an abbreviated equation every time an acid can be written abbreviated wise. Okay, we don't need the water. With a base, why you need the water for a base is that to make an OH minus, the OH comes from the water, which we'll do one. So it's a great question. So I assume this is crossed out. I'm going to say X equals concentration. I hope that we're starting to write like that. Saves you time. If you just write X equals, you have not established that that equals H plus yet. And that's an important little mini step. I know this is not the exact question on the problem. I'm going a little further, but I don't think that that's going to hurt us. Don't forget to take the square root. Man, is that an issue most of the time. If you have a calculator that you are counting zeros, please let's talk for a moment so I can show you where your SCI button is, your scientific notation, where it will push it into that for you. There's no reason that you should be counting zeros. Keep the integrity of your numbers, please. Don't round if you don't have to. And then lastly, it's very important that you actually say this. If you're not going to write, okay, if you're going to write this out like this and then do an equals, that's great. Then you just do negative log of the number. But for most of us, you're going to say negative log and then you're going to plug it in. Then it is vital. It is vital that you say pH equals. If you just say equals negative log, I could be solving for POH, correct? I mean, there is literally nothing that says that I'm solving for pH or POH. And then you get it, and you get a pH. And anybody, this answer won't even be the back. But Katie, get it? Does that make sense? Is it 0? And I want that. And that's technically only 2 sig figs, technically. But with a pH, we kind of leave it like that. This is a weak acid. I should have an acidic pH still, even if it's weak. I should still have it.
You think the packet, because we got different.
It was only solving for H. Wait, that's not in the back? Jeffrey?
They got like 2.2.
Oh. They are not, they never cross out.
Oh, okay.
They never cross out. Ever. I'm glad you brought that up. I forgot that they'll never assume. They always solve it completely. Good question. But it's less than 5%, so it's okay. But good observation.
On the actual AP test, are we going to do quadratic?
I don't remember ever having one, but I feel like we should know how to do
Or
one.
do you do that on the test? Like, or do
You'll do
they
that.
never
You'll
put
do
it?
this. They'll set it up so you do that. Sometimes it's amazing. Sometimes if there was a quadratic, they'll get you to the point of just write the expression or the values in the expression. I've seen it like that. Like, can you put them in there? You'd be amazed how many people even can't do that. All right, let's add something to this then. I just saw it. Now I'm gonna lose it. Hang on. Oh, let's talk about this for a second. Percent dissociation, by the way. This is a term that is not actually, I didn't actually teach it to you, but it's exactly what it sounds like. That 5% is percent dissociation. So if I ask what was the percent, let's just stay on this for a second. I'm just going to bring this up tomorrow, because this is actually something that, I mean, I could bring this up at any time, and you're like, oh, well, I already know how to do that, because that's just what that's named. Dissociation means that it's breaking up into its ions. So percent dissociation is how much it's breaking up. So it would be just like any percent, part over the whole. So what I would do is take the part over the whole. That's percent dissociation. Okay? And it's got to be a percentage. So when you're all said and done, I mean, technically you're multiplying by 100, you're moving it across by 2. So this is, correct me if I'm wrong, that's what I got. Anybody else? I need somebody else to confirm it because I do not like that calculator. I don't feel confident when I push the buttons, like it's actually registering my, Jenny, you get that? Okay. Like, nothing. It's like, what the heck, what's the point? Well, K is really tiny, so it does not distribute to the other side very much. So it have a 0.024% percent dissociation. That's what that would mean. There's no new math with that. Okay, let's okay, let's just. This is actually just generic. And this could come up, so I want to make sure that we know how to do it. This is just about chemistry in general, and then we'll get into a couple other things. So how many grams of KOH? This is just common stuff. To prepare 800 milliliters of a solution, the pH equals 11.56. Just want, like, if that ever would come up as part of a bigger problem, as I told you, usually in AP questions or in a test, there's always something that kind of takes you out of your comfort zone just a little bit. This is one of those that could do it. So let's talk about this. I want grams of KOH. I have pH and I have a volume. So any ideas of starting points? Jeffrey?
On
Find
POH.
the POH? Okay. So, where am I? Okay. Now what? Yeah.
10 to the negative of that.
Okay.
The concentration of OH.
So, that'd be that so far? Help me out, because I don't even want to do it with this one. I do not like that calculator. I gotta find my graphing calculator.
3.63 times 10 to the negative third.
Negative third? Mr. Blackford?
Good afternoon. You had a student looking for you. So you're gonna make up a lab 9 and 10 tomorrow?
Oh, yeah, I found her.
Okay.
Thank you. All right, so now what, in general? What could you do? Hmm? Yep, so, good. Mom is like said times by liters. What I could do, I'm just gonna make it a little more visual. It's exactly right. Is I could put it into this. Oops. Move that over. And can I get the moles? Right, and then I take my moles and I multiply it by whatever grams of KOH would be. And if you're like, whoa, you're just pulling out new stuff right now, I would love to hear why anything I just did is new. Right? I mean, all it is you identifying relationships. Is it maybe a potential stress? Like, oh my gosh, wait, we might have to be able to pull off something like that. You just got to slow down. Think about what you're given, where you're going, okay? It's important though. So there's a lot of good ones right there. But let's go to 47 when you're done with that. This is a great question. This could be a test question. I just want to calculate this so you got it. Gosh, I really do not like this calculator. This Do you have this one?
Yeah.
I hate the buttons. I feel like it never registers.
It never does.
Oh,
It's the
yeah.
sad part.
Oh,
You probably have a good.
Let me see.
Dude,
Into the TIA.
mine are worn, so.
We get this?
Every once in a while.
Anybody? Is that, I don't know. Okay.
What should you get when you buy the TIA 30?
Okay. Good. 47. Let's talk about this. So the pH of a 0.3 molar solution of a weak base is 10.66. Calculate the Kb of the base. This is a good question. So, what you basically have, not meant to be, is you have a base. So a base would look something like this. I'm making this up. It may not look exactly like this. That's how it would behave. And I hope when you look at that you agree. Like, oh, okay, yep, I see how that works. Like, I'm going to call my base just A minus. You could call it anything you want. Okay, I'm making it up. But you got to have some sort of structure to this. Now, maybe you don't need to do an icebox, maybe you do, but I want to show it to you in terms of an icebox so this makes some sense. As I've said many times, if you're not sure where to go, organize your information in an icebox and you'd be amazed at what you get. Okay, so ultimately, let's talk common sense. This has to equal Kb. Meaning, if I want to solve for Kb, what do I need to know? All of those, right? I need to know all those to get to Kb. And where are all those? I, C, or E? Where are those always when it's equaling a K? The values that get plugged into a K expression are in I, C, or E in the icebox. E. So let's talk about where these numbers go. I think this will really illustrate a lot of good stuff. It says pH equals negative or 0.3 of a base. Well, the pH of a 0.3 molar solution of a weak base is 10.66. So that's the only things it gave me. So the weak base has a point, I'll talk about where these go, and the pH equals 10.66. Which one's equilibrium? Only one of them is. Think about every pH problem we do. pH? Yeah, pH comes from E. So this right here, guys, this is the initial amount. Meaning, just like before, those must be zeros. It dissociates like everything else. Dissociates out. So, what is this going to give me in my icebox, ultimately? Of OH, right? So this would be plus X, like fill it all in. So, what I do, and you can do a couple of different steps. There's two different directions I can do, like I just said, you can do two different ways. Yep, so I could go into POH, or I could get this into H plus and then take 1.0 times 10 to the negative 14th over the H plus. Either way, it's kind of what do you like to do more? I don't know. So, this is 3.34 for the POH. So OH minus equals 10 to negative 3.34. Again, this is a great question. Just because it's simple, yet it's actually kind of complex because you got to understand where things are going to go. Where is that going to go? Right there. What else does that equal in my problem in general? What is that? That's my X. So help me out.
It's 4.57 times 10 to the negative 4.
So that means I have, I'm going to run out of room here, 0.30 minus 4.57 times 10 to the negative 4th, which may not affect that too much. I don't know if that's going to affect that at all. Oh my gosh, it made up a button for me just then. I did not even.
Yeah.
Hey, doesn't get you out of mistakes in your test.
I think it's like a grade higher. Yeah.
I would be a success.
I'd be going to Harvard right now.
One day you'd be like, I wouldn't be vice president at age 50. I would have been CEO by now if it wasn't for the calculator. But I could have gotten a better one at any time. So then you plug in. And this is how I would do this on the test eventually. I'm just going to square it right away, just the same value. Why did I keep 4 sig figs? I didn't want to lose the integrity of that number. If you did it yourself, there was a 4-3 at the end. I don't know. I didn't want to round it. If it did slightly change, I'd rather keep it. What do you get? Sweet. In the back it says 7.0 times 10 to the negative 7, which sounds like that is about what we do.
What did it say in the back?
7.0 times 10 to the negative 7, if you round. I hope this makes sense. Like, think about it. pH always comes from the end. I can easily give you a pH value. This is a great look at this. This also shows you how you write an equation for a base. It's not HA equals H plus and A minus. You got to have that base adding to the water because you have to make an OH minus. And that's kind of a really important step. All right. Quickly, I don't even want to do it on paper, but 52. Just look at it. I guess I'll write on it a little bit, but I don't want to spend a lot of time. I just want to make sure that we're clear. It says, what is the pH of 0.76 molar KOH? I'm not going to do the whole answer. I'll just talk about it. What are you doing? What's the deal? Hunter, what do you do?
Probably OH.
Okay.
That's a strong base.
Is it?
Right, yeah, yes.
Okay. So what do you do?
Automatic.
Caleb, what do you do?
Beats me.
Okay. Anika, what do you do?
You would find the POH.
How do I do that? Of?
0.76.
Why is 0.76? Hunter said I gotta find the OH.
Because it's a strong base.
Because it's a strong base, that is that. If it was a strong acid, the H plus would be the concentration. Because it completely goes to the other side. So that is my POH, and then I just take pH minus that and I'm done. Strong acids and strong bases have as little steps as any problem there is. You just have to recognize that you have to just pull the trigger and say, hey, that is the concentration of the K and the OH. I don't care about the K, I care about the OH.
Wait, so if it was a weak acid or a weak base, what would you do then?
So, good question. Let me just make sure I label this. If this is a strong base right now. So if this is a weak base, okay, whatever it is, let's do this. Let's do one. Here. We'll do it right here. That's a weak base, NH3. First, what else? Incomplete problem. Jeffrey. I need a KB. That would be 1.8 times 10 to the negative fifth. It is not your job to have these memorized. I just have that one memorized. That's why I did it for the problem. So now what do? This is the whole x squared over 0.76 minus x equals 1.8 times 10 to the negative fifth. X equals concentration OH minus. That's the difference.
Wait, why do you need to know the KB? Couldn't you just take negative log
Of 0.76 like that?
Yeah.
Great question. Because this is not equal to OH. This is a weak base. It does not go all the way across.
Okay.
Okay, the KOH means that it goes completely across as hard as possible. The K is infinitely large. So this value is just the same on the other side. This barely breaks apart to the other side. And this tells us how far it breaks apart to the other side. So, important to see. Okay. We'll do one more, for sure. Again, I have some other review stuff. I just want to make sure we get some things out there. We're going to do. This isn't a problem. Just if you want to do it in the back or wherever else, then just hold a piece of paper in the back. Sorry. How do I do that? I want to know the pH. When I mix 0.95 molar, 37 milliliters of it, of LiOH, and 0.47 molar of HNO3, and I have 100 mils of it. What's wrong?
If they're both strong, is that
That's a good thing. It means life is easier. So what am I actually dealing with then? My world then is this. This is my OH life. This is my H plus. So when you're adding acids and bases, this is what we call a neutralization problem. One is there, they both try to neutralize each other until one is standing by themselves. So what do I need to find? Moles of H plus and OH minus of each. I compare them, I take the excess, and I use that with total volume. Do it. Compare with each other or whatever else. This is made up, so I don't know the answer. It's not in the back. So we want to make sure that we can execute it.
what would you do if they weren't strong?
Right now, we're going to keep it like this. Next chapter, we'll deal with that.
Okay.
We'll cross that bridge.
So we only have to worry about mixtures between strong acids then?
Right now. And bases.
And bases,
Now mixtures of weak acids together, or strong acid and weak acid we can do, because then you're adding it and then you add the H plus in there, we have an example of that. Careful of rounding, there's no reason to round in certain points. Why am Yeah.
Why is it so acidic? Oh, 'cause it's just.
Because all that's left is a strong acid. I mean, it's amazing, and you're going to see next chapter when we graph these, it's like acidic, 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 and then a basic, basic, basic. Like it just destroys it. So whatever you have left, it's all pure H plus. So that's all that matters. I have some things that I'm planning for tomorrow, so there's not. Oh, let's just finish up with one last idea. If you're ever given, just to make sure, I'll just write this down for now. Tomorrow we'll do a practice problem, but if you're ever given certain amounts, it still could always come up, and you're trying to dilute or equal, so you're purposely trying to exactly dilute or try to exactly neutralize an reaction of an acid and a base. Don't forget that that this would work. We do M1V1 equals M2V2 when you want to dilute something and make a different concentration, but you can also do this when you want to neutralize a neutralization as well. So you could do if you start noticing, wait a minute, I feel like they're getting 2 molarities, 1 volume, and they're asking for the other one, or 2 volumes and 1 molarity, and they're asking for the other one. Oh, well, yeah, that's that M1V1. That can always show up, and it's just kind of a core idea of an easy route of trying to find the amounts of each. Because why? What does this equal if I take molarity times volume? Moles. Oh. Just I'm trying to make them equal. So this is moles of A equaling moles of B. So that's why it's a neutralization. I'm trying to get it perfect. Well, that's the same idea with the problem I just did above. Just I didn't make them equal. I'm trying to see which one is left over. Okay. So I have some very structured problems tomorrow. I might even print out the sheet just so it goes faster. We're going to pump out just some other ideas. I didn't get to everything today, but I know that we're getting kind of close to time here. But please, acid bases 2. That should be done. That should be done for surely by tomorrow. So you have a better idea of the big picture. I know I didn't get to every single problem, but try to get to as many as possible. So it's kind of tricky. And you go down a lot of different paths. My favorite one tonight was actually at 47. Where we had to figure out where the values go within my icebox. That icebox helps me in many different ways. I thought that one kind of was an interesting way to see how that would work. So we might use a few more problems on here yet, but I do have some structured problems that I just don't want to dig into tonight because I want to do it at the same time. So Ray, if you have additional questions or need any help with bookwork or whatever, let me know. Definitely can help.